Hello students, today's video is a continuation of the lesson that we did while I was gone in March about function operations. This is the one thing that we did not learn about, and that is the composition of functions. So our learning targets today are I can calculate the composition of functions and I can use the composition of functions to solve real life problems. So let's just jump right in. Hey guys, and welcome to your lesson on function operations. This is actually a continuation of the lessons that I left whenever I was out of town in the month of March. We did function operations involving f plus g of x, f minus g of x, f times g of x, and f divided by g of x. That was all the different arithmetic operations we could use on functions. We could add them, subtract them, multiply them, and divide them. This lesson is about the composition of functions. So our learning target for this lesson is I can calculate the composition of functions. Let's just jump right in. Okay, so this example, it starts with example 5, but it says that let f of x equal the function x minus 5, and let g of x equal the function x squared. What is g dot f of negative 3? Now this dot that we see here, this is not a multiplication symbol. The dot stands for the composition of the g with the f function where we're substituting in the value negative 3. So let me show you another way that our notation could look. It means to find g of the f function substituting in negative 3. So basically our g function is our outside function and our f function is our inside function. We're going to work our way from the inside out. So starting here, let's find what is f of negative 3. Well, to find f of negative 3, we replace x in the f function that says x minus 5. We replace that x with the number negative 3. So what is negative 3 minus 5? It's negative 8. So f of negative 3 is equal to negative 8. Well, since that is true, then we can replace f of negative 3 with the value negative 8. So this right here gets to become a negative 8. So now I'm going to find g, oops, let me erase that. We can find g of negative 8 because f of negative 3 equaled negative 8. So g of negative 8 means we're going to substitute our x with a negative 8. So negative 8 quantity squared is positive 64. Therefore, our solution is positive 64. G dot f of negative 3 is 64. Example 6 actually gives us the same exact two functions. F of x is x minus 5. G of x is x squared. But this time, we're not finding g dot f of negative 3. We're finding f dot g of negative 3. So this time, I'm finding f of g of negative 3. So this time my inside function is the g function and my outside function is the f function. We have to always start by working from the inside out. So we begin by finding what is g of negative 3. So replace our x with negative 3. Well, negative 3 quantity squared is equal to positive 9. So g of negative 3 is equal to positive 9. So I'm going to replace g of negative 3 with positive 9. So now I can find f of positive 9. I replaced g of negative 3 with what g of negative 3 equaled. It equaled 9. So f of 9 means I'm going to replace x in the f function with 9. And 9 minus 5 is 4. So f dot g of negative 3 was equal to positive 4. In example 7, we change up our functions. This time we're going to let f of x equal x minus 5, but g of x is a little different. It is x squared minus 2x, x squared plus 2x plus 2. This time, I'm not asked to find f of g of negative 3. I'm asked to find f of g of x and find g of f of x. Another way we could write this is find f dot g of x and find g dot f of x. So this time I'm not substituting a number in. I'm just substituting one function into the other, and then I'm going to simplify the result. So let's start by saying I'm going to find f of g of x. Well, what is my g function? My g function is x squared plus 2x plus 2. So I'm really going to find f of x squared plus 2x plus 2. Well, what does that mean that I'm going to do? That means that inside my f function, I'm going to replace all my x's with this quantity, x squared plus 2x plus 2. So, let's write that out. Oops, back to the pen. Better erase, 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 please erase. There we go. That's not erasing. Okay, we'll pretend that erased. Okay, so this is going to equal, my f function is x minus 5. So my x minus 5. But my x gets replaced with the quantity x squared plus 2x plus 2. So what I'm going to do now is just look for like terms that can be combined. So 2 minus 5 combines to be 2 minus 5 is negative 3. So I bring down x squared plus 2x minus 3. So therefore, f of g of x is equal to x squared plus 2x minus 3. So we found already that f of g of x is equal to x squared plus 2x minus 3. But we're also supposed to find what is g of f of x. Sometimes it could be the same thing, but it doesn't necessarily have to be the same thing. So you do have to find it both directions if it asks. So what is our f function? Well, our f function is equal to x minus 5. So this is the same thing as finding g of x minus 5. So that means in our g function we'll replace all x's with the quantity x minus 5. So I'm just rewriting the g function. The g function was x squared plus 2x plus 2. Replace those x's with the quantity x minus 5. X minus 5. Now what we will have to do, we'll have to take this first quantity x minus 5 and multiply it by itself using the FOIL method. X minus 5 squared means to multiply it by itself. So I will FOIL this. X times x gives me x squared. X times negative 5 gives me negative 5x. Negative 5 times x gives me negative 5x. And negative 5 times negative 5 is positive 25. So that's the result when I use FOIL. F-O-I-L. The next part, I'll distribute the 2 into the quantity x minus 5. So 2 times x gives me 2x, and 2 times negative 5 is negative 10. Bring down the 2 that I have. So my last step is to find and combine any and all like terms. So there's only one x squared term. I'm just going to bring that down. But negative 5x, and positive 2x can all be combined. So negative 5 minus 5 gives me negative 10. Add 2 to that, I get negative 8x. And then last, positive 25, positive 2, and negative 10 can be combined. 25 plus 2 is 27, and add a negative 10 to that, I get 17. So I find that g of f of x is equal to x squared minus 8x plus 17. I want you to notice that when I found f of g of x, I got one trinomial, and when I found g of f of x, I got a different trinomial. They are not the same answer, so the order in which you substitute one into the other makes a huge difference. We would say that the composition of functions, which is what we're finding here, the composition of f and g, or the composition of g and f, the composition of functions is not commutative. That means that the order makes a difference in the answer. The last example that I want to do on this video actually is not on your notes page. As a matter of fact, on the notes page, the two problems on the back, I'm just not going to have time to go over in the video. But if you look at the worksheet that you were passed out, it's the composition of functions practice number 1 worksheet. Let's take a look at problem 5 on that worksheet. It says for the function f of x equals x plus 2, find f dot f of x. So what in the world does that mean? Well, the dot we know means the composition of the f function with the f function. So f dot f of x would mean substitute the f function into itself. That's kind of weird. F of x. Well, what is the f of x function? It is the quantity x plus 2. So that means we're going to replace x in the f function, x plus 2. We're going to replace x with the quantity x plus 2. So you'll see here our parentheses represent this x here. Our parentheses represent the x plus 2. Here is my outside function in red. My inside function is in blue. If I simplify this, it should be pretty easy to see that 2 and 2 combined with as like terms, I get x plus 4. So f dot f of x is equal to the quantity x plus 4. So the composite function is x plus 4. So again, I'll review our learning target for this lesson is I can calculate the composition of functions. Hopefully, you've learned a little bit about what the composition of functions is. It's when you substitute an entire function into another and then simplify the result. Hopefully, you understand a little bit about the notation, that the dot does not mean multiplication. It means the composition of functions. F dot g means to substitute the g function into the f function and then simplify. And you saw that we could do that substitution when we actually substitute in a number, as in the first two examples that were in the video. I think they were labeled example 5 and 6. And then we saw where we just are using the variable x and simplifying, as in example 7. So good luck to you. I would like for you to complete the worksheet today that goes along with the lesson. It is the worksheet titled Composition of Functions, Practice Number 1. If you would complete that, please, the whole front side, problems 1 through 6, and on the back you'll see a standardized test prep worksheet there. Problems 1 through 5 on the back you should be able to complete and turn in for a grade. We didn't get a chance to go through the real life applications with this, so you can leave off the short response on the standardized test prep question. So try to finish this today in class, turn it in for a grade, and I'll see you tomorrow. Good luck.